In example 1, we want to find the particular solution to this differential equation, and that particular solution needs to also match up with this initial condition right here. So when x is -1, the output, or y, has to be 2. This is very, very similar to the previous lesson, which is previous lesson, 7.6, except we're going to carry it a little bit further. So if you haven't checked out the stuff from 7.6, please do that now. And the first step then is going to be to separate your variables. And I wrote an integral symbol, so let's get that out of there. Let's just multiply by dx on each side first. So the dx's will cancel on the left, and we'll have dy is equal to 6x squared plus 6x plus 2 dx on the right-hand side. If you want, you can put a y to the 0 power here to kind of help remind you of what to do in the next step, because the next part, we're going to take the integral of each side. We want to find the antiderivative of the left, which is actually y, or just y to the first over 1. So in this case, we'll just write the y down. Then we want to find the antiderivative of this polynomial-like function. So we're going to do add 1 to the exponent and then divide by that new exponent. So 6 divided by 3 is 2, and then we have 2x to the third power. I always just do a double check to make sure that that works. So 3 times 2 is 6, and we lower the exponent by 1 to get 2. So we do get right back to the integrand, which is that expression inside the integral symbol. If we find the antiderivative of 6x, that's going to be 3x squared. Once again, we could take our exponent, add 1, which is 2, and divide by that new exponent. So 6 divided by 2 is 3. Then we have 2x, and of course, plus c. There's your constant of integration. Before we were done at this step, this is the general solution to this particular differential equation, but we're going to actually find that particular solution. We can do that because we're given a y, so remember that's up here. There's your y value, and there's your x value. So we'll write that down for you. It's supposed to be a y. Oh boy. There we go. So what we're going to do is we're just going to replace the x and the y with what they are, and then we'll wind up being able to solve for c here. All right. So we'll do a little bit of algebra here. We've got 2 times -1 to the third, which is -2. 3 times -1 squared is +3. Remember to do that squared part first. And then we've got -2 and then plus c. So we'll wind up with 2 is equal to -1 plus c. And then, of course, c will be 3 for this one. So to find the answer to this, that particular solution, we're going to go from the general solution. And all we're going to do here is we're just going to replace the c with what we found it to be. So the c for this one we said was 3. So we'll take that c out right here and replace it with 3. We've actually solved this one for y already. It's kind of set up pretty nice for us. In the problems in the future, we'll have to do a little bit of solving work here. But we've solved this for y. We found our value of c, and that is the particular solution that has a derivative of 6x squared plus 6x plus 2 and has this point as part of the solution.